I'm not a Gen Z. I'm a what am I? I'm a Gen X, I think. I'm 56 years old, so I think I'm a Gen X. Am I Gen X? Or am I a Gen Y? I know I'm not a boomer. Yeah, maybe it's Gen X. I don't know. What is Gen X? I think that's the 70s? Because I was born in 68. All right, so I'm going to skip the troubleshooting of this. I'm going to probably contact the manufacturer and see if they can give me some help. But what I do want to do is I want to show you what I'll be working on. So what happened during yesterday is I had a hurricane pass through, and this made me decide on a few things about what I need to do next. So I had to bring in my Hobie Cat into my garage, which is the place that I work. So this is what I had to do. So I had to bring it into the garage. So my garage, my entire garage space, which was actually all of that area there. You can see the trampoline to the right there, and that's part of the Hobie Cat. And now I have it over there in pieces. I actually took it apart. So maybe I'm a Gen Y. Maybe I'm a Gen Y. Okay, so you can see where the Hobie Cat is now. I took apart the Hobie Cat and I took apart the trailer so I could actually fit it. So what that is making me want to do, because I want to get back to working on a spindle for another company. It's the Spinology spindle. I'm not sure if you saw that episode where I show it off. Let me see if I can get another card in here. I'm thinking static electricity caused the problem today. All right, so when I click on the video, will become a little bit darker but less noise, so that should be better. All right, so yeah, the Spinology, that's like a $4,000 spindle that they gave to me for free, and they want me to do some videoing on it, and I'm very excited about it. But this machine here is my workhorse. It used to work all the time until I stopped selling kits and machines, because it was the one that actually, see if I can get over my boat here. So this is the machine that I used as my workhorse. This is the main gantry here, and it's the one I developed back in 2010. And I sold a lot of these machines. I sold a lot of kits, and I also sold a lot of assembled ones. But it's taking up a lot of room. Even though it's like slanted, I want to make room for my boat, which is, it's kind of it's funny because I have a CNC company, but I need to disassemble my CNC machine. So I'm going to disassemble the entire machine in streams, in a set of streams, I think. And I'm going to build another machine, but it's going to be smaller, and it's going to use the new spindle, so I can show all of the aspects of that spindle and showing it working. It's an ATC spindle. It's a spindle that it has an automatic tool changer. You can see I was working all day on getting this boat disassembled so I could have more room in my shop. So another machine I want to work on is, you see that white board over there? Let me see if I can get closer. It is an obstacle course in here. So the white, I can't see the comments right now because I'm away from my computer and my phone has no battery. So that whiteboard, I'm going to get a lot closer to that. It's sort of an X and Y machine by itself, And what my intention was, it's a dry erase board, and my intention was for it to work like a CNC plotter, essentially, just an X and Y, and then the some type of not Sharpie, but like one of these things would work like a solenoid, like it would go in and out from just using a solenoid action, and draw on the dry erase board. But this could be adapted to chalkboards, all kinds of things, where like I've seen restaurants, pretty big restaurants or bars or whatever, they would have a huge blackboard in the back, and they'd have all kinds of drawings back there. And it would be cool to have that kind of mechanism. But I want to redesign this because I didn't like the way I designed it. I kind of stupidly designed the gantry to move up and down, but that makes no sense because gravity is not your friend, and I don't think that's a good way to design a board like that. The gantry really should be vertical, and then it would move back and forth in this way. So there's you don't have to worry about gravity and torque with the motor. The torque shouldn't be a really big issue when it comes to these types of mechanisms. The only problem, I guess, would be the z-axis, or the I guess the y-axis. The y-axis would be going up and down, and the weight of the mechanism that goes, the weight of the mechanism, the weight of the end effector, or whatever you call it, would be the only thing that would require a lot of torque, but it wouldn't really require that much torque because you're only holding something like this. And with my microcontroller series, I want to continue doing stuff with that, but let me see, let me go get it. In my microcontroller series, I usually work with microcontrollers, but it's only a single chip. That's really dark, isn't it? So let me see if I can increase the ISO here. Okay, so I want to try to show, at least for my CNC viewers, how to use a chip like this, with stepper motors and other types of control for CNC machines. I've already developed quite a number of circuits. Let me see if I can find one here. I may not find it. Well, I designed a 3D printer back in, here it is. I designed a 3D printer, a resin printer back in 2010, and I brought it to the New York World's Fair, Maker Fair. And this is the circuit that I developed, and it has an Atmel chip. And what it did is it controlled the z-axis according to each the slice of what the DLP projector was showing. And every time it would have a relay that engaged, I can't remember, this is a long time ago, 2010 that was 14 years ago. It would control the DLP, and it would also control the z-axis, so the item that was being resin cured, actually I've got a bunch of examples of that too. This is an example of what I did back then, something like this, where it resin cured. This is something that, along with this controller, it created a 3D printer that created something like this. And it would have a platform that would submerge itself into the vat, and slowly, like it would just go one layer and it would cure that layer onto the plate. The plate would then go down and then go back up, but slightly deeper. and then the next slice would be shown on top of the resin. So it would eventually get to something like this. And this was a lot of trial and error. 3D resin printers weren't available at that time. This was all like development based on information that I found online. With my own microcontroller knowledge, I developed this board and programmed it. And I was working on, I've been showing microcontroller videos for a very, very long time, and from all of those videos and me learning through that process, was able to develop something similar to this and other circuits as well. And the program, or the machine, was extremely. Let me see if I can show you what it looks like. All right, so this is my screen. That was where I was watching you guys. All right, I've been reading your stuff here, but I'll get to that in a little bit. Let's see if I can see a picture of that machine. Yeah, it's this one right here. It's a really bad image, but so I developed this machine here. You can see the Z-axis. You can also see that controller I just showed you, that circuit that I created. And this is the DLP projector. I had to remove the filtering, the UV filter, to allow it to cure the resin. And this is the vat. It's just a little pan, like a square rectangular pan that would hold the resin. And then this mechanism here, this is the Z-axis, would go up and down, and it would submerge itself into that. And there's stuff that I want to do with this as well on stream. I'm getting back into 3D printing. It's not going to be my machine. It's going to be like an Elegoo or an Anycubic or something like that. Let me go back to the other camera here. Come on. Why aren't you showing up? Okay, here we go. It has to be not minimized. Okay, so what was I saying? I can't remember what I was saying. Yeah, so I want to get back into 3D printing. My 3D printer stuff is over here. Let me show that to you. And I'm going to be working on creating a lab hood type of thing. You can see the Elegoo Saturn back there. And I'll probably invest in a few more printers, because there's a lot of things that I want to do with the printers to scratch an itch that I have with urban design. I'm wanting to do a model of the Noli plan. If you care to know what that is, you can look that up. But it's a plan that was made by an archaeologist quite a ways back. He was an architect and archaeologist, and he made a plan of Rome. And because I'm an urban designer by trade, I have that itch that I really want to scratch and get into urban design as well. But that has a lot to do with the 3D printers. But I also have a reason to get back into it because of my mechanical properties of resin 3D printers. I created a part of my website. Let's see, get back to this. All right, so on the top of my website, I actually had, yeah, right here, new 3D resin comparison table. And you may have seen this already, because I've mentioned it on other videos, that you can look up any resin on the market that I have been able to find, and you can find all the mechanical properties, or as many as I could find for each of those resins, because I also create engineering type of parts that I need to work in machines. So it needs to be able to withstand lots of pressure and stresses and things like that, and impacts. So I've been searching around for the best resin. I couldn't find a table like this online, so I created it. You can also add your own printer settings if you want to. But I worked on this for weeks. This is something that I developed myself on my website. The entire website that I created was all programmed by me. Let's see. So I'm going to be doing testing as well for 3D resins, 3D printer resin, 3D resins. I want to do some testing and fill a lot of these blanks for the mechanical properties of these resins. Of course, these resins are expensive. I won't be able to afford them, so I will probably be starting with the ones that I use, and then I want to show those on streams and have those tests, because for me, I personally like watching tests and see how they fare, see where they fail, and I'm going to be also building the instruments or the tools to use for the testing with the load cells and things like that. So yeah, that's what I have planned. Let me go back to this. So let me go take a look at your comments. Yeah, the CNC you mentioned, that looks epic. Did you build that yourself? You're talking about the what is it? The Green Bull CNC machine that I have back there. Yes, I designed that back in 2010, the entire machine, and that's something that I've been really. That's what essentially allowed me to survive in this company. Okay, love your shop. Sort of like a plotter. Yeah, the one for the XY and the writing. It would be like a plotter or dry erase plotter. I really like your plotter idea. I actually need something like that. That's awesome. It would be awesome to hook that up somehow to a 3D scanner to make floor plans. I think the live stream is really, really behind. I'm going to check out the live feed on my. I'm looking at the feed on my live streaming. Okay. No, it's good. Yeah, no, it's fine. Okay. All right. So what do you guys think of the plans that I have? And is there anything that you guys want to see in my streams? But the process of creating a brand new, let me show you the Spinology spindle. I've been keeping it under a piece of towel here. Or a towel, a hand towel. So this is the spindle. I've already had, like I said before, I showed a video about this one, and it has sensors. It has outputs to show what the sensor readings are, and I'm going to be connecting that to microcontrollers as well to view those sensors and do some ADC. The air to change the tool, and let's see, what were these again? Oh, this is the water. Okay, so it's water cooled. So this is the an inlet and outlet for water. So I'll be showing water cooling as well, and the temperatures of the water, making sure that it's cool enough. So there's a lot that's going to go into the spindle and show the various features of the spindle, and also the control of the spindle, the changing tools, making sure that the specifications are met with the spindle with regard to temperatures of the water and the pressures of air, and also, like I said, sensing or reading the sensors. And I'm going to be building a machine around that. So the machine is going to go through a lot of design. I'm going to use CAD. I'm probably going to be using a Libre CAD, and I'm going to show that off because it is a spectacular CAD program. I used to use let me look at your comments. What kind of material will that thing mill? It'll probably mill. It can't go that slow because of the type of spindle it is. It's a 2-pole, which it can go down to about 12,000 RPM. So that's a little bit too fast for working with steel, but aluminum, it's going to be fine. Brass, those types of materials, wood, obviously, plastic. The machine is going to be designed through a Libre, but I'm going to be using common off-the-shelf, like C-channel. I don't want to use 80/20 like a lot of people use. I think that's something that everybody uses, and I want to go a little bit away from that and it's going to be more like my Fabricator Pro machine, but it's not going to be that machine. So the Fabricator Pro is this one right here. Let me see if I can show that to you. So this is the Fabricator Pro, and it is all aluminum. This is a C channel right here. But the problem with this is it runs on roller chain, which I like roller chain, but it doesn't have the precision that I want for working with machining in metals like aluminum and stuff. It does fine for just general, like if you want to make signs and things like that. But if I want to make anything with any tolerance, I want to use a ball screw on all axes. So I'll be designing something like this, but it's going to be ball screw driven. And it's not going to be this big. It's probably going to be, well, this is the 6x12 that I've made. This is a 4x8, but it's probably going to be even smaller than this. I've actually made an 8x17 for a customer in Wisconsin. And it's literally, like, it's huge. I have videos on that, on me putting that together on my channel as well. Yeah, the 80-20, oh yeah, look at that. I don't know how to read your name. Lamb the Rod Light. Yeah, a Libre, that is the software that I use. It is absolutely spectacular. So happy to know that you are using that software. Yeah, I have a place in my heart for people that want to sell their software and allow you to own it. Not have to worry about subscriptions like Fusion and Inventor and SolidWorks. Yeah, let me, no, I'm not going to show that to you. If you want to see that other machine, you should take a look at my YouTube channel and look for the 8x17 machine. He's a guy out in Michigan, and he creates these fish farm structure things that requires a huge machine. So that was a fun one to do. So yeah, so a Libre is I know the developers. They're good people. I was going to sell their software, but I told myself that I'd rather just put a link on my website and just allow them. Let's see. Let me show that to you, just so you're aware that I have it on my website. And software, where's software? There it is, all the way on the bottom. So I have a Libre here, but you can see that they're just links, and I'm putting these links out there for free. I want them to succeed. I want them to grow. Their design, I think, is in, or the expert is, I think, in the thousands of dollars, but their Atom 3D is $399, and it has so many of the features of the design. It's just, you don't, I can't remember what you don't have, but I think you can't import like Inventor files or something like. I've got the design because they gave it to me for free, so that is one thing that I do have that that is a plus for me. But it's still cheaper than Inventor and SolidWorks. SolidWorks is it's like $10,000 if you want to own it, but you can still do a subscription with them. And I used to use Inventor exclusively. Inventor was I loved Inventor, but there was so many issues that I had connecting different parts in an assembly and allowing them to work parametrically together. So I decided to try out a Libre, and they talk to me. They love they have so much passion that I think it would be a crime not to help them out. Fusion is a ripoff. My 3-year subscription ends this year, and I want to bail on them. Yeah, definitely learn a Libre. And also, this is becoming an Libre stream, but look at their YouTube channel. They have every video you can think of on how to use their software, and I can't think of anything that I can't do there that I could do in Inventor. So I can still connect all of my. Look at this. See, this is way back in the past. I don't know why that's showing that. I'll just hide it so I don't see it. So yeah, I can't remember what I was talking about now, but yeah. Okay, so that's that. Yeah, and I think I talked a little bit about the price. Yep, Adobe is the same way. They just want to make a subscription of everything. It might be the only way it's sustainable, but still, you know, I just don't like that. I mean, they've been doing that for such a long time, and they're able to survive for such a long time with that model in the past. Why can't they do it now? So, not really sure, but yeah. Yeah, I mean, I in my architect and urban design days, I learned through AutoCAD. That was my software that I needed to use for industry. And I'm an AutoCAD expert, but I don't want to use them anymore because of their subscription model. The integration from a Libre to 3D printing is absolutely seamless with their native file format. It's been instrumental in my tool prototyping. I make tools for the oil and gas industry. Let me show you something that I do make if I have it. I may not have one in stock. No, I don't have one. Oh well. The anti-backlash nuts that I make, that I sell, are 3D printed using a tough resin, and I've literally sold thousands of those anti-backlash nuts. See if I can find it here. Where would my anti-backlash nuts be? Mechanical, yeah, mechanical. All right, so this anti-backlash nut right here is printed on the resin printer, and it fits perfectly with the screw, with the a 5-start 1/2-inch Acme screw, because it's designed in a Libre, and I was able to design it as per the specifications of the screw, and it works perfectly. And I've sold thousands of these anti-backlash nuts, and I've had 2 customers they broke, but one of them broke in shipping, and that was from probably poor shipping. And I had I think rails or screws or something that was like right on the end of the package, and it crushed the nut. And I had another one that had the threads stripped out somehow. That could have been a mechanical failure on his end, or it could have been something wrong with the resin when I was curing it or something. But 2 out of 1,000 minimum 1,000 is pretty good. It's pretty good for 3D printing something mechanical. So a Libre is incredible, and I designed this in a Libre actually. The screw. So yeah, let me know what you guys want to see. Do you think what I am thinking about doing in these streams? You guys are my super fans, because you're the viewers that showed up on this stream, which is I'm very grateful for. So I want to hear from you guys. You know, if you can also leave a comment on the video. I'll keep the live video in the live section, and I may also take these live videos, and I may do supercuts of them, because they may be good for other people to see. So if you guys want to see anything specific, or you think what I'm planning is something you'd like to see, or maybe you want to see something different, let me know. Thank you, Chlorslug. You too. So yeah, let me know what you guys want to see, and the videos of the machine, building the machine and designing it, will be many streams. So this could take a very long time. So each stream will have hopefully something beneficial for you guys. So with that, I think that's it. I think 2 streams in a day is good. So I hope you guys enjoyed the stream. Thank you for coming in and allowing me to talk to you guys and see what I was doing. Hopefully I will see what I can do with this controller, and if I figure out what's going on, I'll put it in the comments of this stream, and potentially do another stream about that one. Thanks, Scott. Appreciate that. All right, guys. Thank you for coming by.